farmer from Southeast Manitoba, where I run a organic grain farm with my dad. So normally I talk about my research in precision experimentation, but as Bruce mentioned today, he suggested I focus on the farmer side of things and how farmers interact with this precision experimentation idea and some of the challenges they face. So it correlates nicely with Bob's talk from yesterday, and hopefully it can add to that conversation. So normally when I talk about on-farm precision experimentation, I always start with a picture of this field here. And again, the twist is that I work in organic systems. So how do you apply precision experimentation in organic systems where they have unique challenges of reduced nitrogen, no chemicals, and often weeds? And so here's an organic field from Montana. You can see the hilltops there where there's very few plants growing. And that's indicative of a Montana system where there's lacking moisture. And then in the far, you can see if you can see, maybe there's a bit of a darker patch where there's more moisture and the crops are growing better there. And then you can also see these really dark green circles, which are weed patches. So those are perennial weeds, Canadian thistle and field bindweed. And so those are the challenges that organic farmers are facing. And we think we can deal with that using precision experimentation, using seeding rates rather than as our input of variation. And so that's the system that I work in. And normally I talk about my methods and research involving that. But again, today I'm going to talk about a little bit about the farmer side of some of those challenges that we face in putting that in. And so in putting together this talk, I wanted to look at some of the interfaces on some of the web pages. And the very first thing I did was I tried to sign into the Trimble web page, and I got this error message, and I just thought that was perfectly indicative of a farmer's experience with precision agriculture, which is just things don't work sometimes, and you have no explanation for why they don't work. So thank you, Trimble, for that excellent picture. Okay, so a little bit about me. So I farm. This is a map of North America. Here's Bozeman, where I live right now, obviously doing my research there, but I'm from Winnipeg, up in Canada, where I run a farm with my dad, 750-acre organic farm. We grow wheat, hemp, oats, alfalfa seed, along with a number of cover crops in that system. And we also farm with my cousin and uncle, who have a much larger conventional farm, and they're pictured there with their newish combine. And I just point that out. We have this nicer, newer John Deere equipment because we are able to piggyback on their system. So that's nice from a precision ag standpoint. We have access to those tools. Okay, so usually in our precision ag talks or jumping onto any of these precision ag websites, we often see pictures like this, and they're really nice and they're very idealistic about how these systems should work. And it's just like, there's a map and the tractor just drives perfectly. And, that's good. That's helpful for our talk to explain what we're trying to do. But the on-the-ground reality is often quite a bit messier than that. And so I want to explore a little bit more about what some of that stuff looks like. So here we have a John Deere monitor in the tractor trying to put in a seeding rate, and we get this prescription error pop up. And then it's got some message below that, which isn't very helpful to the farmer. And then you have to go through that and try to figure out what that actually means. And often that involves long conversations with John Deere tech people to try to figure out how to actually work around this problem. Here we have a picture of a protein monitor map. So we had this experiment laid out. This is the green here is the yield map, but we had a variable rate experiment laid out on this field. And then in Montana, where we want to get at the protein data as well as the yield data, our protein monitor picked up all of the headlands where we didn't have experiments and then just stopped working in the middle. And so that's another problem that we can get. And that seems to be an issue we have with these protein monitors sometimes, where they just jam. And then, of course, crop failures. That's something, if anyone's ever worked with a farmer, obviously that's just part of the system that we work in. And then, of course, here we have a tractor. This is us seeding in Manitoba this year. We basically had to keep a larger tractor around all season because it was so wet that we basically once a day would be stuck in the field pulling the tractor out of the mud. So anyway, those are just an idea of some of the challenges that we, please. Well, there's a wet spot, and I was driving it, and so I saw the wet spot too late, started turning away from it, and then it just kind of sucks the tractor into it. Well, okay, I mean, it was not the technology. This is a newish field for our farm, so we didn't know it as well, which is part of that problem. And B, it was just a really, really wet season. So yeah, I wouldn't blame the technology on that particular one. Yeah. Yeah. No, that's true. You know, I probably did check my phone for a second and then start slipping and then sure. Yeah. No, yeah, and I don't want to necessarily just throw blame at things. I just want to highlight these challenges that we do have to work around them. So this is again one of these pictures we've seen a bunch of times in the last couple of days. Just the methodology of precision experimentation. So starting with our experimental design, collecting the data, modeling, coming up with new maps, and again, I just want to focus on this part. So we have the data analyst over here, and then we give it to the farmer, and then the farmer hands it back to the data analyst. And I want to focus on what those in between spots where the farmer's working on it. So here is our seeder on our farm. And I just wanted to highlight some of the things that can go wrong with the variable rate seeding equipment. So this is the seeder where most of you probably know this, but that's where the seed is coming out of, going through these tubes into the disc part. And each of these tanks has the option of being a variable rate seeder. And what I just wanted to point out is that there's a lot of moving parts going on with this equipment. And on each one of these, there's a gear essentially that is able to change rates. And you can change that manually with the handle, but there's also a motor connected to that will change that. And that's the whole idea that can be done on the go automatically. And my main point is just that there's a lot of areas that this system can fail along the way. So we've had this gear get so jammed full of dirt and dust that you can't even move it with your hand. We've had the individual motors break so that even once we've got the whole experiment uploaded, ready to go, the software is all functioning, the motor itself stops working, and then there's nothing you can do except order that part and hope that it arrives in the next few days. But in the meantime, you have to get the crop seeded. So yeah, this is what it looks like when it works. It's nice. It pulls up the map. But again, even then you run into these prescription errors and you have to work around those things. Yeah, and so part of that is also always having backup plans for these things. So if something does fail, this is our completely randomized map of what we might want a seeding rate experiment to look like on a field. But if the hardware breaks, then we can still put it in manually by getting out and just changing that gear every 5 rows or so. So that's not the ideal statistical methodology, as we heard in that talk yesterday, but we are still able to put out experiments even if something falls apart. Yeah, was there a question? Oh, okay. So yeah, so obviously not as statistically sound, but still able to gain information, putting these experiments out manually. And then I wanted to highlight this picture. So this is a yield map off of a combine from a wheat crop. And you can clearly see there's some machine error going on in here. Like, yes, this is a better yielder. The darker green is a better yielding area, but there's these like essentially white boundaries around this part. And I know from harvesting this field that this area was done on the second day. And so there's some sort of day effect that has happened with this data. And, for a farmer to look at this yield map for the first time, they would say, well, that data is garbage. There's clearly machine error. I mean, it's clearly doing something different on the second day as opposed to the first day. And there are ways we can clean this data, which we've talked about in the last couple of days, and that's important. But just thinking about the farmer's perspective, if there's a way to show them how the data was cleaned, if we could highlight those points and explain how that data is cleaned and whether there's a way to explain, like, for instance, perhaps we would throw out the points around this area, but the core of it is still good. And if we could show that to a farmer, that might be helpful for gaining their trust, but also getting better data out of the system. Here's another issue we had where we put in the experiment and the spot that's not seeded is intentionally not seeded. That's a wet point on the field. But we were able to get the data off of the tractor in this instance, but none of the input rates recorded. And so we had the GPS location, the widths of all the rows and so on, but the actual seeding rate didn't go through. Well, it went into the field, but it wasn't recorded. And so that was an instance where I was with the farmer because it was his first time putting in an experiment. And so I actually knew exactly what all the rates were, so I could add them manually later. But that's not a great situation for long-term application or scaling to thousands of fields, for example. So just another thing to be aware of, probably working closely with the farmer the first time they put in an experiment to make sure these things work. Another issue is multiple combines. So that's more common on larger farms where there are multiple combines growing across fields. This is an instance where we weren't aware that they necessarily were going to use multiple combines. And so you can see there's missing data chunks in the middle of the field. And so that just becomes a logistical problem of collecting the extra data, adding that back into the system, but then also possibly correcting for a different yield monitor, which may be recording on a different level. Yeah, I already pointed this one out. So protein monitors, which are more important in Montana, where we really think about protein as an important output and making sure that those are functioning properly. Yeah. And then, yeah, so these are things that we can't control at all, weather and crop failure. These are, of course, probably many of you know about, have experienced these with running experiments. This is a hailed out wheat crop. You can see it's all bent and broken over from storm damage. Here we have, in the last couple of years in Montana in particular, we've had a very strong drought. So this is a barley crop from early July. You can see it's just completely dead, not yielding anything. This was this particular field, this third picture here is a field that the farmer calls Volcano because it's such a high mounded top. And it picks up a lot of wind speed across there. And so the wind has actually destroyed entire seedlings, crop seedlings that we put in experiments based on that wind damage. And then in Manitoba, where we're obviously dealing with quite a bit more moisture in southeast Manitoba, oftentimes too much moisture rather than too little. And you can see we've got significant areas of drown out across the field there. Yeah, and then changing plans. So probably all of you have experienced farmers changing their plans on the go, and that's just part of the system. Here's a field where, again, this is an organic field. So what you're seeing here, this is a hemp crop from a couple of years ago, and part of the field we've swathed it because there's so much weed pressure there. We just swathed it and to control those weeds, and that's a huge chunk of the field that's been taken out of production because of that weed pressure. You can also see, I think here you can see there's truck tracks from putting a manure pile in the middle of the field, and that's variation that will sort of arrive randomly and then dissipate over time. So that's one of those legacy effects to be aware of as well. Here was a really interesting problem that we had. So we planted oats this previous season, underseeded to yellow sweet clover. And the idea being there, you get the oat crop the first year, the yellow sweet clover is a biannual, so it'll be underneath the crop, and then the second year will take off and you can use it as a forage or a cover crop or till it in as a green manure. But what happens and what we discovered with our seeder is if you're running two seeds through the seeder, the seed blockage monitor will only tell you seed has stopped going if all the seeds stop going. And so with oats, which are capable of bridging with their hulls on them and so on, especially if you're upping the rates wildly, the oats stopped seeding, but the clover kept seeding and just in a section of the seeder. And so we have these strips then that are run across the whole field, multiple fields where we were unaware that oats had stopped seeding. It kind of goes around all of our checks. Our sensors aren't telling us that. And then even if when you go behind the seeder and look in the ground, you'll find the oats in most of the areas, and the oats will be going down in the seeder. So it's sort of a tricky problem. And if we do intercrop with oats again, we'll have to figure out a workaround for that. And here's a picture of one of those fields where we have those clover strips growing in the oat field. And so that's some unexpected variation for sure. And then also here where you see mower tracks, that's where we are mowing out thistle patches. So again, another source of variation on organic fields. And then this gets again more into the data cleaning side of things. This field needed to be swathed to harvest it. And we knew there was a storm coming, but we had a narrow window where we had to swath it. And to keep it up on the straw, it's recommended you cut at a diagonal. And so then our yield data comes in at a diagonal to the seeding rate strips, which went in straight across that field. And so then that brings into question how accurate that data is going to be when you spend less time in the prescription area with your combine. Okay, so a little bit about navigating My John Deere. Probably many of you have interfaced with this before. It works, but it's not as easy as you want it to be, for sure. So here's an instance where one of our farmers started harvesting, maybe decided it was too wet or it wasn't the right day to be harvesting there, so shut it off and came back a different day to finish it. And so we get incomplete data like this if they've punched in a different field name or something like that. And that takes a lot of headaches to try to sort your way around that. Right, the poor interface. So learning how to be able to download data off of My John Deere is a bit of a headache. And just recently they've put out the new map look, they're calling it, which actually buries it even further to pull the data off of there. So again, these are all things that have workarounds, but for a first-time farmer or someone interested in precision agriculture, it's complicated to figure these things out. And then we have one farmer who likes to name all of his fields something new every year, and that just puts these layers over and over and over again. You have all these layers just building up. And here you can see they've driven along the road while it's recording, and that just introduces plenty of headaches for trying to find the data you're looking for. Trimble, yeah, okay, so downloading the data off the Trimble, yeah. Oh, yeah. Okay. Yeah, okay, thanks, Chuck. Yeah, so the Trimble monitor, oh yeah, I wanted to just point out, is very easy to get, or it tends to be very easy off most of these monitors that I've worked with to get the data off of the monitor. You put a USB in and it downloads quite simply. But then actually working with their online services, even once you've paid the subscription fee and have access to it, can be quite an issue. So again, I signed on to Trimble just this week. I got that error message here again. I think I just clicked on one thing and it said error. So this again is just a very common part of the problem in dealing with these things. I think, Bob, you said you had a package or a PDF of navigating all these things, and yeah, and that would be great, especially for sharing with our farmers. But also just thinking about that must need updating on a continual basis as well, because they're always changing these web pages. And then there's that picture again. Yeah, and then just thinking about also retrofitting old equipment. So some of our farmers in Montana in particular have some of these older machines where we've added yield monitors and added protein monitors. And that's something that works, but it adds a layer of complexity again when you have these different producers of these equipment. You know, if it's not all John Deere, it tends to get along not as nicely. And so that's just another layer of data management that we need thinking about. Okay, and then I wanted to talk a little bit, so that was sort of my challenges part of the talk. Now I just wanted to highlight a couple things that we've used precision ag for that aren't precision experimentation, but we've found useful, just kind of random things that we didn't even expect would be helpful. So as I said, this year in Manitoba was quite a wet year. So harvesting our wheat, in Manitoba we have a very short growing season. So when it's time to harvest, you really have to get after that window. And going across the field, we switched our mapping to moisture mapping so that we could see what parts of the field were ready to harvest and which parts weren't ready to harvest. And we could actually control how we planned our harvest across the field based on where the wheat was ready and where it wasn't ready. And that was something that we had never done before, but actually was quite helpful. Yeah, and then augmenting scouting with drones and digital maps. This is also something that we found very useful. Yeah, question. Oh, 5. Cool. Yeah, so augmenting field scouting. So, you know, from our perspective as farmers, we're never going to stop walking across the fields and looking at the crop and exploring how the crop is doing in different parts of the field. But drones can also add a lot of information and really give a quick snapshot. I mean, this is a 300-acre field here. Obviously, there's plenty of variation. There's a creek going through there. There's hot hills. There's low areas. There's places where we weren't able to seed because of the moisture. And adding those pictures to walking across the field can really help us understand what's going on in that system. Yeah. So the question is, what are the best potential applications of using drones for scouting? Yeah, that's a great question. I think on an organic system, finding the weed patches is super helpful. And you can pretty quickly see those as they're coming up in patches across the field. And then that gives you a chance to complete some kind of management from an organics perspective. Non-organically, you can start to very quickly, I think, see areas on the field that are performing well versus poorly. And, if we take a drone shot like this, we can also pinpoint how we're going to scout this field. So you can see like, oh, this is all kind of the same. So we can just walk here and get a sense for how the field is doing here. And then what's going on here where there's a weak patch. Is there something we can do about that and basically help us pinpoint how to sample or where to walk to get a sense of the field? But I think it really depends what system you're in, I suppose. But I think there's a lot of potential there. The challenges, this is literally just a visualization. Challenges would be adding more detail if we wanted to systematically scan a field with a drone to know what weeds are where, then we have to get into the classification of all of that. Drones are relatively inexpensive. The drone I use costs $400, and this is just a DJI Mini, and we get great pictures of the field. It doesn't do anything beyond that, and we have to fly it ourselves and so on. But yeah,
Challenge with the drone on mapping is flight time and dollars and how much accuracy you have to give a system to lack on the map. And then your biggest cost is you got to have 5-6 batteries or a generator. So you keep recharging the batteries, because 100-acre field, I've tried mapping fields. 100-acre field, for every 100 acres, it's an hour worth of flight time. Battery life is 45 minutes. And that's the best drones out there are only 45 minutes.
Yeah. And on this little drone here, it's about 15 minutes. So
but if you're just taking up a snapshot, that's where you're just coming up taking a big picture of the whole field.
Yeah.
Not trying to map anything.
Yeah. But go ahead.
Yeah, one of the interesting things that's kind of happening in my area is the farming population is getting older. My father-in-law, he can't walk the fields anymore. And he always jokes that it's been twice as long as you have month. But what he does, he uses the drone to survey his crop from the pickup.
Mm-hmm.
Doesn't use it for, like trying to make maps. He just wants to get up and see it. And so there's quite a few people around the shop or around the coffee shop to do that.
Yeah.
But it's almost educating them on how to run it.
Sure.
Cell phone poles.
Sure.
They're doing all kinds of
Yeah.
Up and down, and they just don't understand.
Yeah. This is a DJI Mini 2, and you literally just hook your phone into it and away it goes. And it almost couldn't be easier to fly this thing.
Yeah, he's trying to connect his phone.
Okay. Yeah. No,
Struggle.
yeah. These are really, really good points. But no, if we're talking about digitization of drones, that's a whole nother spectrum, and I don't have a lot of expertise with that. But no, we're just using it for these generic scouting. So anyway, I'll just finish up here. We've used precision ag to find where we've had a manure pile in the past, using underneath the snow by finding those specific locations. We use it to track thistle patches, also rocks that we might come back later and do something with. And then again, just one more point is that we can, for new land, so this field shown here, we've only run it for a couple of years on our farm. And so being able to pull up maps and look at the detailed elevation on that field is very important for knowing where the water is flowing. Look at an NDVI map to get a sense where the weeds are coming up early in the spring, and then an NDWI map to see where the moisture might be collecting and plants are collecting that moisture. And that in Manitoba, where we're thinking always about where the water is flowing across a field. So I'll skip that part and I'll finish up there. So in conclusion, it's complicated. We think it's great, but there's a lot of fail points that we just need to be aware of. And then also with precision ag, you can let your niece drive the combine and she thinks she's driving. So there we go.